Hi everyone, this is part two of the Catalan number exploration that we started, and I'm just gonna take some time to remind you of what we did in the last video and introduce you to what's next. The goal of this one is to take the recurrence relation we came up with last time and to utilize that to come up with a generating function for the Catalan numbers. And eventually, the goal will be to take that generating function and actually extract a formula for the Catalan numbers from that generating function. But it's going to take a little bit of thinking to pull that off. I noticed in the last video it was a little tricky to read some of the stuff I was writing on that paper, so I got a Sharpie and I'm using that to write some things down. I also have a whiteboard here. I've kind of pre-prepped some things with that. So hopefully this will maybe be a little bit better than than the last one. We'll see here though, because I'm also doing it in a different environment, namely at my house. All right, so here's what I want to do first. So I just want to talk you through what I've written here. So what I did is I have put down the definition of the Catalan numbers. Okay, so it's the number of ways to multiply n numbers together, k1 through kn. Okay, and what I mean by that is that so if someone gives you a bunch of numbers to multiply together, you're going to say, well, how do I do that? I have to sort of decide how to pull that off. Now, what you might do naturally is just start on the left-hand side and multiply K1 and K2 together, and then that becomes a number, and then you multiply that by K3, etc. And what you're doing there is you're basically parenthesizing from left to right. Okay, but that's not the only way to multiply these numbers together. There's lots of ways you could parenthesize these numbers to pull that off. And so last time we figured out, oh, basically what you have to do is decide where to chop this thing. And you think of it in two groups of numbers. And from those two groups of numbers, depending on where you break this product, there's like a little sub-problem that is to count the number of ways to break this thing up. So you could either break off the first thing and the last n minus 1 things. And so that's where in this recurrence relation I've written right here, you get C1, the number of ways to multiply one thing together, times the number of ways to multiply n minus 1 things together, plus C2 times Cn minus 2. That's what you would get if you broke off the first two things and the last n minus 2 things. Plus, etc., all the way down to where if you took the first n minus 1 things as a group, there would be Cn minus 1 ways to multiply those things together. And C1 is, well, now I'm thinking of that last number as being all by itself. And this recurrence relation, apparently works for, all n bigger than or equal to 3, as we saw. And we had this initial condition, C1 is equal to C2 is equal to 1. Okay? So that's kind of an obvious initial condition. Of course, if I have just one number, you're done. That's it. And if you have two numbers, you basically parenthesize those together, and there's only one way to pull that off. Okay, so we're going to make a generating function. Okay, so Cx is given by, there's no zero term here. It's just starts with 1, okay? And Cx is C1 of x, C2 of x squared, plus C3 of x cubed, plus etc., okay? And here's what's interesting. We can invoke the recurrence relation. Of course, look at this. C1 is equal to 1, and so is C2. So come on, those first two terms, that's just x plus x squared. But then I can invoke the recurrence relation on the first or on the third coefficient. That's equal to C1 C2 plus C2 C1, right? And so that's really what's sitting next to x cubed. And I wrote the next term there just for completeness, namely that C4 is equal to C1 C3 plus C2 C2 plus C3 C1. That's what's sitting next to x4, and I think at that point you can kind of see the pattern of how this is going to go. But I mean, just look at that thing. If you stare at that for a minute, you start to realize, oh man, that looks like something that we've done before when we've multiplied power series together, generating functions together, where you basically collect the terms next to x to a power, and the indices add up to the power. And indeed, that is what's going on, okay? There's some kind of product way of representing this thing. So what I'm going to do is I'm going to manipulate the Catalan number generating function, bearing in mind that it has this interesting form once we get beyond, the cubic term. And so we're gonna kind of think about that together. And what I've done here is I'm gonna switch over to the whiteboard, okay? And I've already kind of started this thing, and I just want to show you what's going on with this. Okay, so I have c of x given by this, and what would happen if I squared this thing? Well, obviously, you just write out the power series times itself like this, but then we got to start multiplying this thing together. So what would be the coefficient of x squared? Well, it would be C1 C1. Yeah? Okay, that's what that is right there. C1 C1. What would the coefficient of x cubed be? Well, you would take C1x times C2x squared plus C2x squared times C1x. So that's the coefficient of x cubed. Yes? See what I mean? So look at that. That's C3. That thing right there, C1, C2 plus C2, C1, that's C3. Amazing. Okay, and then so in this way, we're going to be able to actually manipulate this thing to the point of, realizing what's happening. So what about x4? Okay, so, if I want x4, I'm going to have to take C1 times C3 plus what? Plus C2, C2 plus C3, C1. Yeah. Okay. Close parentheses. And that's the coefficient of x to the fourth. Plus etc. But then you start realizing, oh man, we squared the Catalan generating function. We have C1, C1x squared, and we have these things right here. But seriously, that's just C3 again because of the recurrence relation, and that's just C4 again. And in fact, C1, C1 is just 1. Okay, so what is this? Well, C1, C1 is just 1, so this is going to be x squared, okay, x squared plus, okay, look at this. That's just C3. C1, C2 plus C2, C1 is C3. So this is C3x cubed. Amazing. Plus, all right, C4 x to the fourth plus etc. Okay? So when you square the generating function, you end up with something that looks kind of like the generating function again. Okay, and so if you go back to what we had before, namely that Cx is basically x plus x squared plus c3x cubed, etc. Okay, well, what is this thing? It basically looks like it's Cx, but we've just taken away the x term. Yeah? It's Cx, but we've taken away the x term. Right, so this is Cx, the original generating function, minus its first term. Yeah? So overall, what we realize is that c of x squared, and this is sort of amazing. I mean, let's sort of think about this. If you take the Catalan generating function and you square it, okay, you just end up with itself minus x. Okay, and that is remarkable. And this identity is really the key right here. That the square of the Catalan generating function is equal to itself minus x. And that identity, which again, it came directly from the, it came directly from invoking the recurrence relation and then thinking carefully about things. That identity is going to be the key to actually solving the Catalan recurrence relation. Okay? I'm going to leave it at that. And you might say to yourself, oh man, this is a cliffhanger. Well, good. It'll make you want to learn more about it. We're going to take this thing and actually find a formula for the Catalan generating function. And then we're going to take that formula and actually solve the Catalan recurrence relation. All right? So again, I know I don't want these things to get super long, so I'm going to go ahead and stop this video for now. But remember, we have a nice identity for the Catalan generating function, and we just need to manipulate that now. All right. See you next time.